Now that we've seen how all of these functions can behave, let's look at them all come together with all of these different kinds of functions. This is the very generalized form of it, with once again Dotson being the stand-in for any kind of function that we might have. A multiplied by whatever function it is with x minus h in the middle and plus k on the outside. Let's recall that the plus k is referring to the vertical shift. The x minus h, this h right here, is referring to the horizontal shift. And the a that sits on the outside is what helps us know about flips, stretches, and squishes. And we drew a nice little diagram before to help us understand stretching and squishing. So let's apply our knowledge through and throughout. We're going to do a couple of guided ones in order to really walk us through, hey, what is A, H, and K, and how can we determine what kind of transformations happen. Starting with this f of x right here. Negative 7 into x plus 5 squared minus 11. This will be a little bit scrappy, but do follow along. We're going to look for our a first, and that's going to be this thing right here on the outside of the core function. That core function is this thing right here, the x squared. So this over here is my Dotson, because that's where the new function thing is being applied through this squared. So negative 7 is being multiplied on the outside. Let's recall, when we have a negative a, we know for sure that this will flip. And we also know that this number here is in that range of stretching, because negative 7 is going to be all the way out over here. So here, we say that it flips and stretches. Now let's look at the next thing. This thing sitting on the inside, this plus 5. Remember, this one was tricky, but we have x minus h. So if we had x minus h, we knew that it would be a right way shift. While it was x plus h for whatever reason, it'd be a left way. X plus 5 over here indicates that it's going to be a leftward shift. So here we say that it shifts left. Finally, the last thing we haven't attended to here is the minus 11. Here, 11 we know is going to be negative. Duh. So, in this case, k refers to the vertical shift, so we know that it's going to move, or shift, down. I should also specify shift down by 11, and shift left by 5. And that's all I would really ask. And I'd ask it in a very guided fashion, in such a way that you'd only have to fill in blanks or circle a difference between stretch or squish. Let's look at the next one right here. For a case of the square root function, g of x is 1/10, x minus 2, all square rooted, plus 1. We need to know a, h, and k here. Over here, the number being multiplied on the outside is none other than the 1/10, because the main core function here is the square rooted part. H over here, since I have x minus 2, and since I know that we reverse that sign on the h, it's 2. And k is the number on the outside, so it's 1. With an a of 1/10, it's not negative, so we know we have no flip. And it's in that in-between range between negative 1 and 1. Remember that little line right here? That this was the squish range. So in this case, we have a squish. No flip, and squish. Meanwhile, over here, I have x minus 2 on the inside. Since we have x minus, we know that it's going to be a right shift, so it's going to be a shift. Right by, in this case, since it's 2, it's by 2. And finally, the easy one, the k being added on the outside. That means that we shift in an up and down fashion, Since k is positive, it shifts up by 1. 2 more examples right here. I'd like you to give them a try as you tries, with a little bit of a hint. Keep in mind that x squared is a core function, and sine of x is also a core function. You guys are rock stars at this. I know you can do it, and I'll see you on the other side.